Hello y'all, this is Nature's Space and welcome back to my channel. Today is going to be an RS-25 hot fire test. This will be one of the last hot fire tests in preparation for Artemis 2 of the SLS rocket. The SLS rocket will contain 4 RS-25 engines. They are all hydrolocks and one upper stage engine and one module engine for the Orion capsule and the Orion service module. Artemis will also have
Welcome to NASA's Stennis Space Center near Bay St. Louis, Mississippi, and the live broadcast of today's scheduled RS-25 engine hot fire on the Fred Hayes test stand.
Yep, as you heard, this is going to be happening on Fred Hayes hot fire test stand.
Operators and engineers are testing RS-25 engines here to help power human missions to deep space as NASA explores the secrets of the universe for the benefit of all. Four RS-25 engines manufactured by lead engines contractor Aerojet Rocketdyne help power each NASA Space Launch System rocket at launch.
Yep.
NASA has designed the Space Launch System rocket to fly astronauts and cargo on Artemis missions to the Moon and eventual missions to Mars. Each RS-25 engine used to help power Space Launch System missions is first tested and proven flight-worthy at NASA's Stennis. Developmental testing for new RS-25 engine components and performance parameters also is conducted at the center.
Yep.
To date, NASA Stennis has tested RS-25 engines for the first 4 Artemis missions. NASA Stennis tested the 4 RS-25 engines that helped launch the successful Artemis 1 flight around the Moon and back in late 2022. NASA Stennis also has conducted RS-25 developmental testing as Aerojet Rocketdyne prepares to produce new engines to launch missions beyond Artemis 4. Aerojet Rocketdyne is using manufacturing techniques such as 3D printing and state-of-the-art components to reduce production time and cost for new RS-25 engines. Today's hot fire is one in a series of certification tests of an engine manufactured with new processes and components. Certification test will help demonstrate Aerojet Rocketdyne is ready to move forward in producing RS-25 engines for future Space Launch System missions. During today's test, operators will fire the RS-25 engine for about 8.5 minutes, or 500 seconds, the same time engines must fire during an actual launch. The RS-25 engine will power up during the hot fire to the same level required during a mission launch, producing up to 418,000 pounds of sea level thrust. At altitude, the engines produce as much as 512,000 pounds of thrust each. RS-25 engines are fired using a mix of liquid oxygen and liquid hydrogen. Liquid oxygen and liquid hydrogen are cryogenic propellants that must be stored at super cold temperatures. Liquid oxygen is stored at minus 280 degrees Fahrenheit. The temperature for liquid hydrogen is even colder, measuring about minus 420 degrees Fahrenheit. Propellants for a hot fire on the Fred Hayes test stand are provided by a 40,000-gallon liquid oxygen tank and a 110,000-gallon liquid hydrogen tank located atop the stand. Fully loaded, the test stand propellant tanks can power a 350-second test. For hot fire tests longer than 350 seconds, like today's is scheduled to be, additional propellants are delivered by transport barges docked nearby. The docked barges are connected to the test stand cryogenic piping systems. In addition to propellants, operators flow as much as 170,000 gallons of high-pressure water to the test stand during each minute of a typical hot fire. Most of the water flows from the NASA Stennis high-pressure industrial water facility to protect the test stand flame deflector from damage by the super-hot engine exhaust. The pressurized water sprays into the flame deflector through thousands of holes strategically designed to direct the water spray where needed. The high-pressure water mixes with super-hot exhaust to produce a massive steam cloud seen exiting the test stand during a hot fire that is often mistaken for smoke. This steam cloud billows into the atmosphere and, depending on conditions, can condense and fall as raindrops in a very limited area. The steam cloud phenomenon gives rise to periodic and erroneous speculation that NASA actually has a rain machine. As one would expect, safety is a prime concern during all hot fire activity. No personnel are allowed on the test stand immediately prior to and throughout an RS-25 engine test. Operators and engineers conduct the hot fire from a fortified test control center located a few hundred yards from the stand. NASA personnel also have established boundaries for viewing RS-25 engine tests in order to ensure the safety of observers in the event of a hot fire anomaly. Throughout the day, operators and engineers have been working through a lengthy pre-test checklist of preparatory steps and activities. NASA is committed to testing like you fly, which means the pre-test process mirrors the one following in preparing for an actual vehicle launch. Teams now are approaching final preparation for today's test. Please enjoy today's certification hot fire of an RS-25 rocket engine on the Fred Hayes test stand at NASA's Stennis Space Center. Stay tuned following the test for updated information and a chance to view a NASA Stennis video titled Part of Something Great.
A quick fact: I touched one of these engines. Um, that I'll post on my community post. I have touched one of these engines before, so I know what it feels like. It was very good to touch this engine. The engine I actually punched it, and it's this strong. But yeah, in 3, 2, 1, 0. All right, that's the done. We're not doing a plus. We're not doing a T-minus count. It would be too hard to do that. Because of reasons. So we're just gonna do the plus. We don't actually know if we don't get a T minus count, but if we do get a T minus count, I'll put that sucker up there so we can get a plus count. So yeah, I'm gonna be adding T minus and P plus, which stands for plus, and then T minus, whatever minus sign. But yeah, getting ready to see a hot fire test from Stennis Space Center, Mississippi. I'll be ready at any time to start this plus count. So let me just do a quick little test at 3 seconds. So let me make sure that everything is working well. Plus 10 seconds. Okay, it works. Surprisingly. Let me make sure. Okay, it's at max quality. So y'all get the most enjoyment. Personnel at this test stand, as you heard from her, she said all personnel will be like a couple hundred yards away from this test stand, ensure of anomaly if anything happens. so they keep it like far away. All right. We're coming up on the test in like a couple minutes to seconds. You heard her say that uh we're finishing their final pre-launch or pre-launch test uh, checks, and they're getting ready for this hot fire test in about a couple minutes. Could happen at any second to any minute. We should get a view of the RS-25 engine like a couple minutes to a couple seconds or moments from that. We should get to see the engine that's doing it. But yeah, they're gonna start making more RS-25 engines. These some of these engines were launched on space shuttle like Endeavour and stuff. Lance's Enterprise, nah, Challenger, Columbia, and Columbia and Challenger did not get recovered because they both burned up or blew up. Yeah, overall NASA killed over 10 people or over 12 people, and they still haven't got or they have got jeopardized for it. Uh, yeah, let's talk about something more important for today's hot fire test. This is gonna be my first hot fire test. Sorry I couldn't stream it because I was somewhere else, but as usual, I'm gonna post the length of this video, which is 36 minutes. Um, I'm going to treat this like if it was a stream, but there's nobody here, so yeah. We're about 4 minutes away, so I'm going to get my count up. We're under 4 minutes and 55. All right, 3 minutes and 55. All right. We should be getting some engine views soon, like any second now. Go, but we're still good for this test. We're T-minus under 3 minutes almost. Here's some sound. Getting ready for this hot fire of the RS-25. We're gonna get an engine view in a couple seconds to a couple moments. In 3, 2, 1, 0. We should be getting it in like under now. It's about 20 minutes. We're coming up on 20 minutes since the stream started. Ooh.
A hot fire test of an RS-25 engine is scheduled to begin soon on the Fred Hayes test stand at NASA's Stennis Space Center. Please stay tuned.
Yes, indeed, I will. It should be happening like an engine view like right now. T minus 1 minute and 45 seconds. Okay, I'm ready to start my plus count. Whenever it happens. I'm always prepared. I'm prepared for the worst. We should be getting engine review right now. Where is the engine view? We got some sound and we got a new update, but no engine view yet. We want to say is the engine view. We love a good NASA test. We're under 58 to 55 seconds. If this estimated time won't work, then I will move on to just waiting until the engine starts. There we go. T minus 20. Seven, 6, 5, 4, 3, 2, 1, 0. And sorry, there's no T minus counts. Ready to start the plus counts? Engine ignition should be in a couple seconds, a couple minutes, or a couple moments. Engine ignition, we're under 1 minute, realistically. You can see some frost, since it's been snowing. I think that has nothing to do with it, because this is normal. But engine ignition should be, happening any moment now. Sure, I will be quiet, like the first minute of this test to get a feel of the rumble. And then I'll start doing commentary, or if anybody else does commentary, then I'll be quiet, but still. We'll do some commentary. This is Hydrolox. This this is a very special engine. It is fuel rich and pre-burner rich, or I think it's fuel rich, but still, this engine was the first American solved fuel rich problem that was solved with this engine. This engine continues to go on a rocket that's going to take us back to the moon. Engine ignition should be happening in like any second now. Right, and you can. There's ignition plus count activated. And there goes this. Okay, that thing's going back. And the engine is ignited. Plus count is on. All personnel in control of this RS-25 engine. Everybody's on. commentary neutral space and RS-25 engine is running. The engine looks like it's moving forward. Planned burn time of about 8 minutes to 5 minutes. This is the first hot fire tool. T plus 2 minutes into this hot fire test. Or T plus 4. About 2 minutes into this hot fire test. This 500 You have a cutoff. 8 minutes and 20 seconds burn time. Or NASA's time, 8 minutes and 21 seconds. Wow. That was beautiful. That hot fire.
This concludes the live broadcast of today's RS-25 engine test on the Fred Hayes test stand at NASA's Stennis Space Center. Please check the NASA Stennis website and social media channels for additional information about today's test as well as upcoming hot fires. Thank you for tuning in and for your ongoing support of NASA and NASA Stennis. Please join us now in viewing a NASA Stennis video titled Part of Something Great.
You have probably driven past it, seen the name in the news, perhaps even met someone who works there. But what do you really know about NASA's Stennis Space Center? There are a lot of facts, but here is the important one. This nation is headed to deep space, back to the moon through the Artemis program, including with the first woman and the first person of color, and then on to Mars. The country has put its trust in NASA's Space Launch System rocket to fly farther than ever before. And like before, Stennis is testing the very rocket stages and engines that will help launch those deep space missions and send astronauts to other worlds. This is what we do. We help power space dreams, right here in Mississippi, right in our own backyard. That makes each one of us part of something great. Go NASA. Go Stennis.